Hi, so this is part 2 of your lecture that I left off, your 15-minute lecture. We need to finish the irregular objects that we were starting. So I said we had like this magnet that has a hole, it's round, it's not very big. So how do we find the density of it? So what we're going to do is we're going to take our graduated cylinder and we're going to fill it up. So I'm going to fill it up to a certain point. Doesn't matter what point, it just needs to have enough in it to where it will fully submerge. It cannot be floating. You cannot find the volume of this if it floats. So we need this to be heavy enough that it'll sink in the graduated cylinder and that we will get the right amount of water above it. So again, like in the past, what we're going to do is we're going to take this graduated cylinder and we're going to put it on a flat surface. So we're going to put it on my desk right here. Oops. So you'll see it. I'm going to get down at eye level like I did last time, and I'm going to look at what it is. So I'm going to look and I'm going to see that this looks like to be about 20.3 milliliters. So I'm going to go ahead and write that down on my board over here because that's the volume. So VI, which is initial volume, anytime you see VI, it means initial volume. So I'm going to put VI and I'm going to put my writing down. So I'm going to go ahead and plug that data in. Now I'm going to take this and I'm going to put it in the graduated cylinder. But I want you to be aware of, I'm not just going to drop it because it's going to break the glass because this is a metal and it's heavy. So what I'm going to do is I'm going to slide it in there. Oh, this one's too big. So what I would do is slide it in there and it would go all the way down. This one's too big, I need a bigger graduated cylinder. So anyway, if it was anything else, you'd slide it in, it slides all the way down. Just rest it against the side and slide it all the way down, and it'll change the volume. Now I've done this lab already, so I already wrote down the change, and so the final volume ended up being 25.6. So VF, which is 25.6. Now what's going to happen is I'm going to take VF minus VI, and that's the final volume minus the initial volume to get me the volume of this magnet. When I do that, I get 5.3 milliliters. So this is what you're going to do. For irregular shape, I already found the mass. So I did that ahead of time. So I found the mass on the triple beam balance, 2 places past the decimal. The volume initial, which is what I had written down. The final volume, which is what I already knew because I did it. And then, of course, the V, you're going to do the V and the VI, which is right there. I subtract them, and that's what I get. So now we have our volume, which is 5.3. We have our mass, which is 20.38. Now what I'm going to do is I'm going to do mass divided by volume, and that will give me the density of an irregular shape. So I'm going to take mass, put it over volume, and remember, you always got to show your work. Work is important, so you always got to show your work. So this is what it looks like if I write it out. So now what I'm going to do is I'm going to take up my calculator because I can't do this in my head, and I don't expect you to either. That's why we have technology. That's why we have these things. So I'm going to go ahead and plug in 20.38 divided by 5.3. And I get, if you did this and you're following along and you're actually trying to calculate, which you should be, you should get 3.85. So density equals 3.85. Now what's the unit? The unit is different than a regular object, because in a regular object it was grams per centimeters cubed because we actually measured this. This one is grams per milliliter because we used a graduated cylinder. So that is what our density would be like, would be grams per milliliter. So if I gave you, let's say I want to find the volume, say, okay, I need to know the volume of this, but you're given density and you're given mass, okay? So you don't know, you're not gonna, like it's an object, let's say it's a flat piece of paper. Let's go there. Let's say it's this flat piece of paper right here. It's a flat piece of paper. We'll say this is like a 12 by 12. It looks like a 12 by 12 centimeter flat piece of paper. So I give you a 12 by 12 flat piece of paper, and I want to know what the volume is. You're going to have to do things differently. You can find that using the density formula, and you're going to have to manipulate the equation. You'll know the mass. You can find the density. Then you got to figure out volume. Now be careful because it's flat. So now you got to take in consideration area. So because when you find this volume, it's going to be in centimeters cubed. So we can do this, and if we're going all the way through to find like the thickness, because it's small and it's paper, then we're going to want to go to use the area to find that centimeter. So we'd have 12 centimeter, 12 centimeter, and if you want that thickness, then you're going to have to go a little further and use area to figure that out. I'm not going to work through that, but I will give you a hint that may be something you want to know for later. So if I'm doing this, and let's say I want to know the volume. So using our triangle, remember, I showed you that triangle for a reason. So we're trying to find volume. So if I cover up the V, wrong side, it's backwards. So if I cover up the V, we know it's mass divided by density. So volume equals mass divided by density. So we know that that's the equation, okay? We mass it out. Mass is like 1.26 grams. We know the density because we looked up the density of paper. And let's say the density of paper is like 4.56 grams per milliliter. Nope, grams per centimeters cubed, because it's a regular object. So this is what it would look like. Oops, right there. Take out your calculator, and then you're going to find it. So I'm going to go 1.26 divided by 4.56, and my volume would equal 0.028. Now make sure you can get these numbers too. Now the problem is, Ms. Crandall, what is the units? Well, what happens to these grams right here if we look at this? So what happens to the grams? Well, you notice gram is over gram. Boom. They cancel out. Well, since that centimeters is grams, it's going to be centimeters cubed. And if you think about it, we know all the units. You know that volume is either milliliters or centimeters. You know the mass is grams. You know that density is grams per milliliter or grams per centimeters cubed. So you can easily figure it out that way. You don't have to like crisscross match it out. If you can remember what it goes with, it's not that hard. So that ends the unit. A little bit on safety, on some of the equipment and how to properly read it, which you should remember, and then a little bit about density. So you should be prepared to do this lab that we're about to do. So I'll see you in class tomorrow. Have fun.